All right, students. Okay, so our topic today is about annuity. Okay, so this is business mathematics week 4. Okay, so all right. Okay, so learning outcomes. At the end of this lesson, the student should be able to understand concept of annuity, apply the concept of annuity to business related problems, then model the present and future value of annuity. Okay, excuse me. All right, so what is annuity? Okay, so the annuity, okay, in our daily life, most of the people want to have a big amount in the future, right? But few of them want to save some amount at present for the future. Okay, so however, many people save small amounts on regular basis or at interval to complete future requirements, right? So this is the fact on which annuity is based. An annuity is defined as a series of payments made at an equal interval with the charging of compound interest. The period between the consecutive payments of an annuity is known as the payment interval. Okay, an example of an annuity is the depositing of 12,000 in saving account every 4 months for a year. Okay, so characteristics of annuity. Okay, there are some important characteristics of an annuity. First, the sequence of payments may continue for a short or long time period. Example, there must be regularity in payments. Second, throughout the given interval, the amount of payment is fixed. Then, number 3, there is a constant time interval between two consecutive payments of annuity. Okay, it could be weekly, monthly, quarterly, or annually, and etc. Right? Okay, so next is the money growth rate remains constant, okay, during the interval of annuity and charge compound. Okay, so number 5 is usually the time period or the rate of interest is annually, but it could be compounded monthly or quarterly. Okay, so these 5 are the characteristics of annuity. All right, so there are also types of annuity. Okay, so first, ordinary annuity. Okay, so for our ordinary annuity, so if each payment, okay, rewarded at the end of every payment period, so or at the end of the time period and continues for the next fixed period, this is known as ordinary annuity. Or this is annuity is also called ending mode annuity. Okay, so because the payment is made at the end of the period. Okay, so for example, monthly saving from the income. Okay, so that is the example. Second is the annuity due. Okay, so if each payment done at the start of every payment period and continues for the next fixed period, so this is known as annuity due. Okay, so as in this annuity payment is made at advance, so it is called beginning mode annuity. So for example, if a person is living in rental house, he or she has to pay rent of the house in advance at the start of the month, right? Okay, so that is the meaning of annuity. Okay, so if you have question, then you can just comment, no, in the comment section. All right, next is perpetuity. Okay, what is perpetuity? Okay, so perpetuity is if each payment paid at the end of every time period and continues for unlimited time period, this is known as perpetuity. Right? So for example, the scholarship awarded to a student continually from the grant. Okay? So that is perpetuity. Next. Okay. basic calculation with respect to annuity. So there are two basic calculations with respect to annuity. Okay, so calculation of sum or amount of annuity, then calculation of present value of annuity. Okay, so calculation of sum or amount of annuity. If payments are made in an account like ordinary annuity or annuity due, which enabled to receive an amount at the end of the annuity. Okay, so the sum or amount of annuity is defined as the lump sum amount. Okay, so to be received at the end of the annuity. So amount of annuity is the amount that is the sum of payments, and all interest earned. All right. Okay. So later on, no, there will be computation or examples for this. Okay. Okay. Of course, now this is the how do you call that one? Definition, no, of calculation of sum or amount of annuity. Okay. Here are the formulas for calculation of sum or amount of annuity. Okay. So sum of ordinary annuity and annuity due can be calculated using the following formula. Okay. So for ordinary annuity, the formula must be S is equals to R, okay, bracket, open parenthesis, I plus 1, close parenthesis, raised to the power of n, minus 1 over I, close bracket. All right? So later on, if you identify or if you can identify what is the value of R, the value of I, or even the value of the exponent, then you can just put it there. Right? Then solve it according to the formula provided. Okay, so for annuity due, the formula must be S is equals to R, bracket, open parenthesis, I plus 1, close parenthesis, n plus 1 minus 1. Then over I. Close parenthesis, minus R. All right. So as you can see, no, there are, there is distinction, no, for the formula. But yeah, of course, no, because when we solve this, no, we are looking for ordinary annuity or annuity due. Okay, so depending on our inquiry, okay, whatever our quest or inquiry, then that will be the formula that we will use later on. Okay, so for that formula, okay, so there is meaning, no, for each variables used. So where S is the sum or amount of annuity, R indicates per period regular fixed period payment, and shows the number of periods during the term of annuity. And I shows the compound interest rate per period. Right? So now you know what is S, what is R, what is N, and what is I. Okay? Next. Okay, example. Calculate the amount of an annuity of $1,500 payable at the end of every year for 12 years at the rate of 6% compounded annually. Okay, so what are the given? So what our R here is 1,500. Okay, what is R again? R here stands for indicates per period regular fixed or periodic payment. Okay, so that is 1,500. Okay, and our N here is 12 years. What is N? N shows the number of periods during the term of annuity. So the problem here indicates that it's 12 years. Okay, so 12 here will be our N. Okay, our exponent. Next, what is I? Okay, our I here is the 16%. Okay, no, this is 6% rather, no, not the 16%. Okay, this is 6%. Okay, payable amount, no, okay, so 16% or 6% rather, not 16, sorry. So 6% is equals to 6 over 100, and it's equivalent to 0.06. Okay, so this is our I. Okay, so stands for the 6% here. All right, so this is my bad. Okay, next, to calculate the amount of annuity, we know that the formula of the sum of an ordinary annuity is S is equal to R bracket open parenthesis I plus 1 plus parenthesis raised to the power of n minus 1 over I. Then close bracket. All right. So S, replace the value of R, which is how much? 1.5. Okay. Then what is I? Okay, our I here is 0.06. Okay, so you cannot, okay, guys, okay, you cannot directly put the 6% there. Much better if you convert it first to decimal. All right, I hope it's clear. Okay, so here the I here is 0.06 plus 1 as it is the given. Then our n, what is our n here? It's 12 years. Okay, so our n will be raised to the power of 12. Okay, minus 1 over I, which is 0.06. Okay, so actually you can solve this using the method of PEMDAS, but if you have, or I advise you to use your scientific calculator if you have, okay, so that you can come up with the same answer. All right, so if you have your calculator or scientific calculator, not just an ordinary calculator, much better if you use it. All right, but if in case no, you don't have scientific calculator, much better if you have to go to the Play Store and download the application if you have smartphone, right? So if you have an Android phone, then you can go to the Play Store and download this application, Hyper Scientific Calculator. Okay, so this is similar to scientific calculator, okay, or the real scientific calculator. You can use this for this calculation so that you can easily get the answer, right? Sometimes if you just solve this manually, okay, you can come up with the wrong answer. Let's say, for example, you have to multiply first the parentheses, since that's the rule of PEMDAS. Okay, parentheses, the raised to the power of 12, then minus 1 divided by 0.06, then multiplied by 1,000, 1,500. Okay, sometimes you can come up with the wrong answer. All right, so I advise you to use scientific calculator. Then the second option, if you don't have, then you can go to the Play Store and download the Hyper Scientific Calculator. Okay, so I hope it's clear. Okay, so when you solve this one using the scientific calculator, so the remaining number will be, okay, so supposedly, when you solve this first, okay, the remaining number will be 1,500 times 16.8699. Okay, but later on, no, you can just, if ever, no, during our assessment, you can just reduce, no, not reduce, but uh, you can just get at least the two decimal points. Okay, not just like this 4. Okay, so the answer, so when you multiply 1,500 by 16.8699, so the answer is 25,304.91 dollars. Okay, but actually when you solve this directly with your scientific calculator, the answer will go directly this one. Okay, so okay, so if you have question, then please leave a message in the comment section. Okay, the purpose of present value of annuity. Okay, this is calculation of present value of annuity. Okay, so the purpose of present value of annuity is to reverse of sum or amount of annuity. So the lump sum amount which has been taken at the start of the annuity and returned in future is the present value of annuity. So the actual amount and its attention on outstanding balance in the form of an annuity. So this is a present value of annuity, can be calculated using the following formula. So for ordinary annuity, this is P is equals to R bracket 1 minus parenthesis I plus 1 close parenthesis, raised to the power of negative n, over I, close bracket. For annuity due, okay, so P is equals to R, bracket, open bracket, 1 minus, open parenthesis, I plus 1, close parenthesis, raised to the power of negative, open parenthesis, n minus 1, close parenthesis, over I. Then close bracket, plus R. All right? So this is the formula for annuity due. All right. Okay, so let's proceed to the example. Okay, so an example here, Mr. Ali wanted to deposit an amount now. Okay, sorry. Mr. Ali wanted to deposit an amount now to meet the yearly tuition fee and other educational expenses of his daughter. Okay, he's intended to draw 6 yearly installments of $18,000 each. Okay, this is a big amount. Okay, so the first installment starting 12 months after the account has been established, how much he should deposit now if the interest rate is 5% compounded annually, right? So this is the problem, guys. Okay, so before we proceed to computation, we have to draft the given or list down the given numbers. All right. So the given numbers here, our R is $18,000. Then our N here will stands to the yearly installments, which is six yearly installments. Then our I here is 5%. Okay, 5% is equals to 0.05. Okay, if you're asking why is it 0.05, it's because we have to multiply it with 100. Okay, so as we solve for percentage, all right? Okay, so the answer is 5%. Okay, so we need to find the present value, okay? Or example, the P, okay? So we know that, okay, this is the formula. P is equals to R, close bracket, open bracket, 1 minus open parenthesis, I plus 1, close parenthesis, negative n, okay, or raised to the power of negative n, over I, then close bracket, okay? Second here, no, as it is stated there, no, using this formula, okay, all we have to do is to determine, no? So our P or R here is, what is R? Okay, so our R here is the $18,000, right? So that is our R. Okay, what about our I? Our I here is the 5% compounded annually. Okay, so which is 0.05 plus 1 raised to the power of negative 6 over 0.05. Okay, so the same thing when you compute this using your scientific calculator, you can directly jump to the answer, which is 91,362.45. All right, so if you just solve this manually, okay, so make sure that you follow the rule of PEMDAS. Okay, so if in case that you fail to follow the rule of PEMDAS, you can end up with the wrong answer. All right, so even if you use the ordinary calculator, sometimes the answer is not accurate. Okay, so make sure to use your scientific calculator. Okay, so yeah, so we are in business, then of course, no, we're in engineering here. All right, so we have to use our scientific calculator. But if you know how to solve this direct or manually, then you can do it. Okay. All right, so using this formula, after filling up those variables given, okay, so the answer is 91,362.45. All right, that is our P. Okay. All right, so P. Okay, so all right, so these are the examples of these are the examples of those formulas, no, or our topics. Okay, so application of annuity in business. Okay, there are several businesses that depend on the concept of an annuity. So some of them are businesses of insurance companies, rental companies, goods sold in installments, house building finance corporations, bonds or debentures, and remuneration of debt, etc. All right. Okay. So I think this is the end. Yeah, this is the end of the slide. Okay. So, guys, please, our students, please refer this video, or I will attach this also, this PPT to the Google Classroom. So please also see, no, this the materials, no, okay, so that you can answer the assessment later on. Okay. So thank you for your time and have a nice day, everyone.